Greetings students, welcome to today's lecture. So in today's lecture we will be dealing with your EHVAC systems. So we will be seeing about what is EHVAC system, its application, advantages and its limitations. Okay, so we will be moving on. So first you have to know what is the need for your EHVAC systems. Okay, so these systems provide adequate grid system capacity. Okay, the electricity transmission lines had to operate at 400 kV or 765 kV. So here they're giving the voltage range to be up to 765 kV. But what happens is that the normal transmission line will be inadequate to handle this amount of capacity. So what happens is that we'll be making use of a new kind of system called extra high voltage system. EHV represent extra high voltage. Okay, extra high voltage. Okay, so what are the advantages of this system? If you are seeing, means this system is more reliable when compared to your normal traditional system, and is less constrained electricity capacity. That is, the amount of electricity constraints will be very minimum. Okay, so first thing is that the increase in size of the generating units is directly proportional to the volume, sorry, inversely proportional, because here you can see the volume is inversely proportional to the 1 by times of your, this VL represents your line voltage. So in order to have a very high line voltage, so your volume will be inversely proportional to it. So the second criteria is that your cost will be directly proportional to your volume. Okay, that is, if volume increases, your cost will also increases. Okay, so with respect to your efficiency, if your volume line voltage increases, your current carrying capacity will be decreasing in order to maintain your power. Okay, your power is maintained by keeping any one of the quantity higher or lower. Okay, so if current decreases, means the losses, mainly your I square R loss, will also decrease. Finally your efficiency increases. So this is a normal basic concept involving in your transmission lines. Okay, so where this kind of EHVAC will be used and all, it will be used in your remote steam plants and your hydro plants. Okay, so the number of circuits and the land requirements decreases. Okay, because the capacity of voltage and or the power carried through your EHVAC will be very high when compared to your other things. Okay, so uh, as the line cost decreases, okay, as your line cost decreases, how you can decrease your line cost? By increasing your VL. Here you can see, if your VL is increased, your volume will be decreasing, which finally tends to decrease your cost. Okay, the same criteria is used over here. How to reduce your line cost? Okay, so surge impedance loading you already know. So surge impedance loading is equal to your line voltage divided by your surge impedance, which is nothing but root of L by C. So advantage of EHVAC is that reduction in cost of the conductor. So because you are increasing the voltage level, so the same thing, if you are increasing the voltage level, your volume will be decreasing, which will decrease your cost. So this is the main criteria. So as you increase the voltage level, your cost decreases, so which is makes it to be more economical. So that's what here they have given. So the power loss, they will be connecting with it. First, they will be taking the power to be transmitted P. So it is nothing but root of VL IL cos phi. So your IL will be equal to P by root 3 VL cos phi. Okay. So next is the power loss. We'll be defining all the things. Power loss is nothing but we are taking for your three phase. So it will be 3 times of your I square R loss. Okay. Will be 3 times of your I square R loss. So after this, if you are connecting a star, if you are taking the load to be star connected, your IL will be equal to I. So your resistance per the conductor R will be equal to rho L by A. So here A is nothing but your area of conductor. So this formula you already know. So now you have to replace this R with respect to your resistance per conductor. Okay. So if you are replacing means you will be getting the power loss will be 3P square. So here this I is replaced. Okay, here this I is getting replaced by this formula. Okay, so after this you will be getting the area to be A equal to P square rho L by W VL square cos square phi. So here itself we can take the relationship between the volume and your line voltage. So it is nothing but it is inversely proportional. Okay, so the volume of conductor you will be getting 3 times of A into L because it's a 3 phase. You will be having 3 conductors and the length will be also multiplied 3 times. So you have to multiply this quantity with this 3 into L. Okay, so you'll be getting this value. So if you're comparing this value with your line voltage means, so the volume of the conductor will be directly proportional to your cost, as we have already seen. So here by increasing the transmission voltage to n times, if you're increasing by n times means the cost of the conductor can be decreased by 1 by n square times. So here it not only decreases it decreases by 1 by n square times. Okay, that is if you are decreasing the line voltage VL by 5 times means so your cost decreases by 25 times. Okay, so this is the main thing what you can infer from here. So the second one is improvement of transmission efficiency. So how your transmission efficiency is improved. So here the input power will be equal to output power plus losses. This you already know. So first you have to put your output power P. Okay, and after that so after this talking about efficiency. So this is your input power and this is your losses. So the losses we have got from over here. Okay, so this from here only you have got your losses. So over here you are taking out to be you are assuming your star connected load. So what happens? Your I will be replaced by IL. So it has been replaced. So now your current density is nothing but the amount of current flowing per unit area. Okay, amount of current flowing per unit area. So this is what your J. So your current density is reflected as J. So here we'll be taking the substituting the value of I over here. Then as it's in the denominator, so this will be getting reciprocated. So after this, you have to take P as a common out. So now we have to find a efficiency. So from here, the transmission efficiency is output by input. So output power is nothing but P. So input power is what we have got from here. So from this, the efficiency you have got. So now we can easily tell that your VL is in your denominator. So your that is 1 by denominator. So if you are taking this means this will become VL cos phi by 1 plus root 3 rho L J. So now here you can see your efficiency and your VL are directly proportional. So as eta increases, as VL increases, your eta also increases. Okay. So the next one is reduction in the percentage line drop. Reduction in your percentage line drop. Okay. So here the line drop is IR. So again your R is replaced by rho L by A, and here I by A corresponds to your J term. Okay, so you'll be getting J rho L. So the percentage of line drop will be in terms of your 100. Okay, so here the current density and your resistivity are constants. So for a given line length, that is L, the percentage of line drop decreases as VL increases, because this VL is inversely proportional. Okay, you can see the proportionality. So the improvement in the voltage regulation, okay, how it gets improved means, so the improvement in voltage regulation, as the voltage drop decreases, okay, the voltage regulation improves, because the voltage the percentage of line drop is inversely proportional to your voltage. So from this itself we can infer this statement. The flexibility of future system growth is possible is one of the advantage of EHVAC. Then increase in the transmission capacity of the line, then reduction in the right of way. Okay. So next, coming to the limitations. So here, as the voltage level is increased, you are increasing your VL, so you are in need of more amount of your insulation. Okay, for both for your conductors as well as your towers. So again, more clearance is required. Okay, this we have seen with respect to your SAG. So more distance is required between the conductors, so the length of the cross arms used increases. The transformers, switch gears, and other terminal equipment should be designed to handle high voltage. Okay. The problems or the demerits in EHVAC are the corona loss. Okay, radio interference occurs. The line support also costs very more. So as the erection or the installation will be very difficult in case of this. So over the substation also you need a very high quality equipments for safety purpose. So in case of the environmental aspect, these clearance through, you need a large amount of area basically through the, even through the remote areas. Okay. Next, biological effects of electrostatic, electromagnetic fields. Okay, audible noise, ozone emission, radio and television interference. So HVC AC system in India, some of the system are here. It is Dehar Panipat line. So it is a 400 kV line. Obra Sultanpur line, Obra Kanpur line. So these are all present over in the North India, northern states. Okay. So next is around 765 kV line. Okay. Agra, Gwalior. Okay. So these are some of the things. So in the EHVAC, what they'll be asking is, what say they'll be asking as a 8 mark about the EHVAC system, its advantages, its voltage regulation, and then the limitations. Okay. So that's what with respect to this lecture. So thank you.